All right, gentlemen, this is the thing that I show you how to build in this video. I think it's the best one. Well, it's the one that I like the most. You don't need space age materials like thermium. You need steel for the metal things and petroleum for the coolant. Also, it's transparent, so if you'd like to put some solar panels down here, it will work. There's not one tile up here that blocks the light. The only thing that blocks the light is a thin layer of petroleum that's on top of these airflow tiles. Another good characteristic that I like is, well, first of all, it's simple and it's thin. And by that I mean it's only one, two, three, four. It's like 5 tiles thick here. And I know it's wavy, so I mean, I guess really if you count that, it's like, I don't know, what is that, like 12 tiles thick? This one is also designed so that it sweeps everything. So if you want to sweep your regolith and the metal that comes from the sky and stuff, this one can do that. The last characteristic, and maybe the one that I find most interesting about this setup, is that it's extremely flexible. You can make changes to it and, careful, thought through changes, but you can move things around and it still works. You can put other equipment up here on the platform and everything still works fine. Actually, all of the other designs that I've used that have these same properties, like it sweeps the regolith, it's transparent, it doesn't use space age materials, all of those good things. The layout, the design for them are absolutely like set in stone. If you move one tile anywhere, then it breaks. This one isn't like that at all. You can move things around, you can put holes in it, you can add stuff to it. There's a lot of things in this game that when you build, it's like, it's one room and you build it once and then you can just forget about it forever and it just keeps working. But your space setup isn't really like that. You're going to want to do things like add rockets and make, access ports in it for ladders. I don't know, maybe you want to add some steam turbines down here so that you can harvest more of the heat energy coming from the regolith. There's things you want to do up there and play around with it, and having a flexible build makes a gigantic difference. So as you can see up here, the regolith is, ooh, wow, 400 degrees. What will happen is the hot regolith will fall through the bunker door down onto this platform. And remember, this platform has a thin layer of petroleum on top of it. I unpaused it, and the regolith falls through, it piles up on the platform. You can see the petroleum goes up to the top of the regolith, and that's all fine. Have a look at, remember these appliances down here are only made out of steel, so I just dropped a whole bunch of very hot regolith on top of steel things, and the regolith is definitely too hot for those things. So as soon as the regolith falls down here, it's in interaction range of these temp shift plates you see in the background. And they have, I used temp shift plates made out of dirt because they have a very high specific heat. So as long as I succeed at cooling them down a bit between meteor showers, then they're able to absorb a tremendous amount of heat out of the regolith when it falls down onto the platform, and they do. In fact, they can take out 100 degrees in like the blink of an eye. So even though the regolith is too hot for the steel robo miners and auto sweepers and stuff, it cools down to a reasonable temperature much faster than the appliances heat up. The robo miners will start eating out all of that regolith, and the auto sweepers will begin picking up everything and putting it in the conveyor loaders. Let me talk a little bit more about how the cooling works. Like I already told you about the temp shift plates in the background that cool down the regolith real quickly. Of course, we have to cool down the temp shift plates in the background as well. And we have to keep the appliances like the robo miner and the auto sweepers and the conveyor loaders, we have to keep all of those cool while they're working. Because when they're doing their job, they produce heat. And since we're in space, that heat has nowhere to go. There's a cooling loop carrying petroleum, and that loop goes down into a room of steam to drive some steam turbines down here. But we need a little more than that because petroleum inside a pipe can't cool down the appliances themselves. So I have you'll see it, you'll see everything is built on a slope like this, which, I mean, I'm sure you've noticed that already. At the top of each slope, I have a valve connected to the pipe of coolant that drips out, I think, 20 grams per second down each slope. So if I switch to liquid view, you can see the petroleum. It runs down the slope this way all the way into the bottom. The reason I use petroleum is because it has to be something that doesn't evaporate when regolith falls on it. But petroleum is tricky for space setups for one reason. It's because space scanners have a very difficult time working through the petroleum. So my space scanner down here, for example, this one is at 100% quality, so it's working fine. But if the petroleum that's sitting up here on top of this airflow tile were thicker, then the space scanner would just not work at all. Petroleum is viscous enough that if this were a flat platform and I were just dumping petroleum on one end and letting it run over to the other end, then there would be no chance of space scanners working underneath. So instead, we have a slope for it to run down. And the effect of that is, well, I'm not going to talk too much about the dynamic of it, but the effect is that I can have a nice thin layer of petroleum on each of these platforms all the way down to the bottom. And at the bottom, there's a pump, and the pump just picks up the petroleum that gets all the way down here to the bottom and puts it right back into the cooling loop. So that's how I get petroleum on top of these airflow tiles, but that doesn't cool down the petroleum on top of the airflow tiles. The cooling comes from the cooling loop in the pipe. So the petroleum in the pipe touches the petroleum on the airflow tiles and cools it down. The petroleum on the airflow tiles is thermally in contact with the temp shift plates, and the temp shift plates, of course, get cooled that way, and that's how all of the cooling works. So the slope is largely just for the petroleum. I did some experimenting, and you need about 4 tiles on each platform. Well, 4 tiles is the maximum on each platform in order to keep the petroleum layer thin enough for space scanners to work. I decided that I wanted a 7-tile cycle. So there's 3 and then 4 and then 3 and then 4. Maybe you could do 5, but you can't do much more than 4 tiles per platform. This RoboMiner can't be dug out by the RoboMiner uphill from it. It can only be dug out from the RoboMiner downhill from it. So there's going to be a RoboMiner all the way on the bottom. And if that one gets buried, then it can never be dug out. And that's why the one all the way down here on the bottom has a couple of mesh tiles over it. That prevents regolith from falling onto it, and therefore prevents this RoboMiner from ever being disabled. The regolith that falls on top of those 2 mesh tiles can be removed by this RoboMiner and this RoboMiner over here. So that also turns out to be a very flexible thing. You could cut this off on the right side or the left side, and it would still continue to work. The auto sweepers I have set up on here I didn't even really plan out where to put them. I just sort of popped them in arbitrarily wherever it was convenient so that they could reach all of the places that I liked. Of course, they still have to make some kind of contact with the petroleum that's on top of the airflow tiles in order to keep them cool. One of the other strengths of using a build like this that's very flexible is that you can put extra, other devices on this platform and they'll stay cool and they won't mess up the operation of the whole space setup. For example, I put these transformers here. It uses the cooling that's provided by the petroleum in this whole system to keep itself cool, and I can use that transformer to power the bunker doors up here. I think that's a pretty good overview of the things that make this build special. If you're really good at this game and you have absorbed all of that and you're ready to go out on your own, then I think you're done watching this video. I will show you a more detailed demonstration of building the entire thing and explaining all of my choices and why I think they're good and why I think this is a great space setup. Okay, gentlemen, let's build this thing. So let me show you what I have set up so far. I'm up in space. Here's my whole space. It's all empty. I've set up a ladder so my dupes can get up here, and I put in a heavy watt power cable so that I can, power the stuff that's up here. And I put in a pipe. This pipe will carry. It's already connected to petroleum, a source of petroleum down there. I'm going to use petroleum to do all the cooling in this device. So that's what that pipe is for. Now, if you don't already know the basics of how space works with the meteor showers and bunker doors and keeping things transparent so that solar panels can work and space scanners and all of the basics for that, I'm going to make this video assuming that you know that stuff. So if you don't know that stuff, then you should probably go learn a bit about it. And I have a video that is precisely for that called Solar Panel Essentials. So maybe go watch that one. I'll start out by putting in the bunker doors. I recommend doing them very high. I'll put them all the way up at the top where I would actually build the bunker doors. Just as soon as this game is done auto-saving, there's actually nothing very tricky about building it. So my dupes can just run up here and build stuff, and I don't even really have to pay attention to them. And all right, so I'm going to build it way up here near the top. And so here's my ladder, and I need my ladder access to work something like this. I've already intentionally figured out where to position this stuff so that it's exactly in the center of the map. The center of the map is between this tile and this tile. That line between them is exactly the center. So this side is where I'm going to start building my build, which is designed to cover 1/4 of the sky. So you'll have to go build 4 of these in order to cover the entire sky. My bunker doors are there, but I'm gonna use regular ladders because I think a regolith might melt the plastic ladders up here. I'll put in a bunch of ladders so that my dupes can reach that stuff and start working on it. So I'm going to put in a platform using airflow tiles, and this is the platform that I'm going to build all of my stuff on, like robo miners and auto sweepers and all that stuff. The way it is you have a platform with 3 tiles, and then a platform with 4, and a platform with 3, and a platform with 4. And in order to cover 1/4 of the sky, for the way I prefer to do it, I go downstairs like this until I have 5 of the big tiles. So if I go down like that and then up like that with 5 big platforms, that is 1, 2, 3. I need 2 more. Then that will cover 1/4 of the sky exactly. And that's just something I know from doing this. And since that's the way I like to set it up, I guess that's the way we'll do it. So the slope here has 2 purposes. The main one is I'm going to put coolant, petroleum, on top of these airflow tiles to act as coolant for all of my appliances. And in order to stop it from being very deep, so I'll have a little bit of petroleum on top of here, just a thin film, and it'll run off the side, and only a thin film will be on top of this one. And if you use stairs, it will work out that way, where you just have a thin film on everything. If you were to use one big flat platform, then you'd have to get it real deep on one end in order for the petroleum to run all the way across to the other end. Problem with petroleum is if you have too much of it, then your space scanners can't see through it. Your solar panels will be just fine. But your space scanners won't be able to see through it. They'll have 0% effectiveness, and you won't be able to tell when meteor showers are coming. So the slope prevents that from being too thick and keeps the petroleum thin. The other thing that the slope does, it changes the angle that my appliances have in order to do their jobs. All right, so this has a downhill like this, and you could actually build this all the way across the entire sky at an angle, but that sort of sucks because you end up using a lot of space and stuff for it, and you have this sort of weird shaped thing. So I'm just going to build another one on the other side, but going uphill. Let's put in the robo miners, and I'll explain to you how they work. So I'm making everything out of steel. I'm going to put the robo miners on each of these small platforms. By small platform, I mean one that has 3 tiles in it, and I'll call the ones with 4 tiles in it large platforms. And just on the outside edge, the downhill edge of each of those, like this. And you'll see same thing on the other side, the downhill edge. So this robo miner can reach everything up here on the top. This one can reach everything over here and unbury this robo miner, and this one can reach everything over here and unbury that robo miner. The only robo miner that is in a position where something can't, dig it out when it gets buried by regolith is the ones down here on the bottom. So these robo miners down here on the bottom, if they get covered by regolith, there's nothing that can dig them out. Also, down here on this this lowest platform, nothing can destroy the regolith that's sitting down there. So I'm going to put a robo miner down here in the bottom that's positioned just in the right place so that it can dig out both of these robo miners. So right there is fine. And that's the only robo miner that you have to put mesh tiles above. So if I put it right, I'm going to instant build this so that I can check to see if the ranges work out right. If I put it immediately above it like that, then it can definitely dig out both of those robo miners. Great. These robo miners, once they've been dug out, they can clear that regolith. So those are the only tiles that we need in order to prevent regolith from falling on one of our appliances. What's up next? Let's put in some auto sweepers. So we want to make a space setup that is capable of sweeping everything. So I'm going to put an auto sweeper let's put one right there because it can reach on top of our 2 mesh tiles. Now let's put one right there. And because you see somebody's suffocating. So you'll see I positioned these auto sweepers so that this one sweeps these 4 tiles, the next one sweeps the next 4 tiles, and I can just position the next auto sweeper to sweep the next 4 tiles, and this works out. You'll see that I'm actually not like, this isn't a very planned out like a layout. Like it sort of doesn't matter where I put the auto sweepers, and that's one of the things that I kind of like about this build is that it's okay to sort of fudge the positions of things. So we have our auto sweepers in. I'll put in some conveyor loaders. All right, what's next? So I'm going to put petroleum on top of the airflow tiles, and you have to put, wallpaper, drywall, in order to prevent the petroleum from getting sucked out into space. So I'll do that. Oh, you know what? Holy crap. I'm supposed to be having my dupes build this stuff. I didn't mean to be auto building all of this. I've been auto building it. Well, I'm not going to go back because I mean it's so simple, but I will turn off instant build mode so that my dupes run up here and build these things from now on. All right, the next thing I want is a row of temp shift plates all along here. So as I mentioned before, steel cannot handle high enough temperatures for these appliances to not overheat when regolith falls on them. So I need a way to cool down the regolith enough that it doesn't make my appliances overheat. I'm going to put a row of temp shift plates in here, and the idea is when regolith falls down through the bunker doors onto this platform, the temp shift plates, first of all, they're cool enough and they have enough heat capacity to absorb the heat from the regolith so that the temperature is below the overheat temperature of the appliances. It turns out if you do this quickly enough, then the appliances never heat up enough for them to overheat, even though it's sort of a race, right? Are you cooling down the regolith faster than the appliance warms up, right? It's kind of a race condition. And the winner of that race is you and me. We can cool it down fast enough. Of course, I'm also using very good temp shift plates. So, and I don't think you need nice temp shift plates. Let me tell you the best ones to use. What you're looking for is something with a very high heat capacity. And the highest heat capacity for a temp shift plate is dirt, which is, it seems strange, right? Dirt is the best temp shift plate for something. But yeah, it totally is. It'll never be they'll never get so hot up here that they melt, which is kind of the weakness of using dirt as a temp shift plate. And the strength of using dirt as a temp shift plate is that it has the highest heat capacity of anything that you can make temp shift plates out of. Its conductivity is I don't really know, kind of average, I guess. What is it, like 2? Pretty average. But because of the heat capacity, it makes it really good for this. Now, I know what you may be thinking, like every one of these temp shift plates is 800 kilograms. I think there's a pretty good chance that you don't have that much dirt. In a very advanced base where you're not using your dirt for anything, yeah, I think you could get that much dirt. Um, or if you start in one of these asteroids that just have a lot of dirt, you could get that much dirt. But I don't think. Let's see. So the whole you have about 1 temp shift plate per tile across the map, and there's 256 tiles across the map. So you're gonna need something like 200,000 kilograms of dirt in order to build all these temp shift plates. So there's a good chance you don't have that much. Just remember, and I think you can make these temp shift plates off out of almost anything. Just whatever you make them out of, go for whatever you've got that has a good specific heat capacity. Like I need all this heat to go somewhere eventually, so I need some steam turbines in order to eat up that heat. I'm going to put a room of steam turbines. I want to have room for solar panels above them, so I'm going to put them kind of way down here. Here's some steam turbine room. 3, 4, 5. If I do the math, I only need 2 steam turbines in order to suck up the amount of heat that we need in order to keep things cool enough so that our steel appliances don't overheat. But in my experiments, I found that every now and then you get a bunch of, meteor showers in close succession, and there is a risk of overheating stuff. So it's better to have 3 steam turbines so that you can keep things a little cooler and prevent that from being a problem. I need something in order to keep the steam turbines themselves cool. So I'll put in a thermal aqua tuner for that. I need some automation to prevent the aqua tuner from cooling water off when the water is already too cold. Otherwise, the water will freeze in the pipe, and that's what this liquid pipe thermosensor is for, to tell me when to turn off the aqua tuner. I'm also going to put in a filter gate between that sensor and the aqua tuner, like this, and its only job is to just make sure that once the aqua tuner turns off, it stays off for at least 5 seconds. If that way, the aqua tuner won't turn on and off really quickly. The steam turbines themselves have to be cooled. I'm going to just put a little bit of water in the bottom of the steam turbine room in order to do that. And the reason I'm choosing water to do that is because it's just really easy to get some water up here. I'll put in a bottle emptier right up there to get water into that room. And I'll put in a bottle emptier here in order to get water into this room. Of course, this is all in a place where there's space exposure, so I've got to wallpaper it with drywall so that all of the gases that I put in here do not escape. So this is our cooling thing. I will run radiant pipes through the steam room down here in the bottom in order to cool off the petroleum that's in those pipes, and then send the petroleum back upstairs to do the cooling part. What else do we need in here, guys? Okay, power, of course. I'm going to put in a heavy conductive wire to connect my steam turbines up to power, and another one to connect my aqua tuner up to power. Since this is capable of handling the entire sky, I want 2 pipes running through it. One pipe for the left-hand side of the sky and one pipe for the right-hand side of the sky. I'm not doing the left-hand side of the sky, at least not right now in this demo, so I'm only going to do the right-hand side of the sky. You can't use one pipe for both of them because you need 2 pipes in order to clear all of the heat that the whole sky makes. Any less than that will be not sufficient. So it looks like I'm making these out of aluminum. It doesn't have to be that powerful, but it's real important for this build for the petroleum that's in this pipe to get cooled quite well. Oh, I forgot something. So my cooling loop, I need to make sure coolant gets in there somehow, and I'll use water for that, and I'll just get the water from the output right here. The output from the steam output from this steam turbine will fill up the cooling loop until the cooling loop is full. These are ready to start having water put in them, so I'll put some water in here to keep my steam turbines cool. Enable auto bottle, and I'll put some water in here so that it can turn into steam in my steam room underneath the steam turbines. Enable auto bottle. Which way do I want this to go? I'm going to make it go counterclockwise. So I'll put in a bridge. Put in a bridge right. Oops. Put in a bridge right here, so that this loop moves counterclockwise. Iron is pretty cheap, and in the what you make a radiant pipe out of in this part of the build, it just doesn't matter. So I'm running the radiant pipe across the top of these airflow tiles because that's where the cooling petroleum is going to be. The radiant pipe will cool the petroleum, and that cooled petroleum will cool all of the appliances, and it will also cool the temp shift plates. All right, there's our cooling loop. I need to put petroleum on top of these airflow tiles. What I'm going to do is just drip it in up here on the top and let it run down the airflow tiles to the bottom. And down here in the bottom, I will have a liquid pump to suck it up and, put it away. You know what? I don't want to get into the dynamics of it so much right now, but this is a very weird cooling loop because I will have little bits of petroleum dripping out of it up here at the top of the stairway, and I will be pumping little bits of petroleum back into it down here at the bottom stairway. And the dynamics of all that make creating a buffer very strange for this cooling loop. And I can make a video about why this is necessary, but this cooling loop is so strange that because of those characteristics that you actually need two buffers in order to make it work. Let's take out, I'm going to take out these pipes. Yeah, I'll take those out. So petroleum will come down this pipe and go into my reservoir. And I'm using a reservoir because I don't know how much extra petroleum will be in this whole cooling loop, including the petroleum that is on the stairs. So depending how much happens to be on the stairs, I might have a lot in the buffer or a little in the buffer, and I need to make sure that it's definitely enough in order to contain all of that petroleum when there's a lot in the buffer. So I need the reservoir for that. Now, because of the weird dynamics of how a reservoir works and the fact that we're taking a little petroleum out and putting a little petroleum into the cooling loop all of the time, you can get a situation where in fact, you will get a situation where the liquid reservoir, even though it's, say, half full, does not output full packets of petroleum. It'll be mostly empty packets of petroleum. And when you do that, you have a mostly empty packet of petroleum going through your cooling loop, and then that empty packet of petroleum can be supplemented by your original petroleum source, basically out of this pipe over here, which we'll connect up in a minute. And fill up and continuously fill up your cooling loop with more and more petroleum until it fills up this entire reservoir and reaches deadlock. Whew, that was a lot of words for explaining that. We need another thing in order to prevent that from happening. And that thing is this double bridge. So this creates a buffer space for one packet of liquid. And because bridges work slightly differently than reservoirs do with the way their output is, it doesn't suffer the same problem as the liquid reservoir where it can output a partial packet of petroleum. I know that this is a particularly complex buffer for a cooling loop. I don't know any other way to do it besides literally changing the cooling loop so that it's simpler, so that we don't need so much weird buffer stuff. Now we just need to get petroleum in there. This is our petroleum pipe. Remember, I have it set up just for this purpose. And where are we going to put it? We want it to go into the cooling loop after the buffer. So the liquid flows this direction. We can put it in right, we'll put it in right there. Ooh, look, we can go straight through the reservoir. That's a neat trick. I'm going to route it straight through the reservoir like this, so I don't even have to make a bridge in order to get it out there. But I do have to make a bridge to get it in, like that. There we go. That should load up our cooling loop. Great. Now, the next thing we need to do is drip some coolant onto this top platform. Put a little thing on it like this. There we go. So petroleum that's in our cooling loop will go through the valve and out the liquid vent and onto the platform. I'm just going to set this to 20 grams per second. And I'll do the same thing on the other side over here. I need to put a little bump on the end so that the petroleum doesn't run off that end. I will set it to 20 grams per second as well. 20. Great. And now I'll have petroleum running down my stairs. Down here at the bottom, I need to collect that petroleum and put it back into the cooling loop. So I'm going to put a liquid pump right there, but I can't pump it directly back into the cooling loop like that, the way it is now. So I'm going to get rid of that section of pipe. So the pump will actually pump liquid directly back into this pipe. And I'll build a bridge that goes over that input like this. And that way, the pump takes priority. If it's pumping liquid into the pipe, that's the liquid that goes into the pipe first. And when it's not pumping liquid into the pipe, then the liquid back here that's going through the pipe will be able to move through. Yeah, I've been kind of neglecting the power. Let's do that. I'm gonna need a power transformer to power all of the bunker doors up here, and power transformers have to be cooled. So you either have to run a cable all the way up from, you know, your base below that's not in space where you have a power transformer, or you can put it up here on this platform. By the way, this is an example of another thing that I'm talking about when I talk about this being flexible. You can just add extra stuff to it that's convenient to put up here. That's great. The other setups that I'm aware of that do have all of the capabilities of this one do not have that capability. They are way too restrictive. So I'm just going to run my heavy watt wire through all of the things that I need to power. Let's see, what else do we need? We need a conveyor rail for all of my conveyor loaders. There's the end of my conveyor rail, and I'll just stick a conveyor chute on there. I'll set up these auto sweepers just to sweep everything. Oh, I need to put power into the bunker doors. Let's do that real quick. Oh, you know what we also need is scanners. I'm gonna I'm gonna blueprint in some solar panels so that I can figure out where to put the scanners. Because if the scanners are too close to solar panels, then the scanners won't work. The space scanners, they need to be above the solar panels, but they also need to have 14 tiles between them and other things that will interfere with their operation. I can't put them over here because they'll be too close to stuff, so I got to put them over here where there will be space for them to be. In order to have enough warning before a meteor shower to close the bunker doors, I need to have 2 space scanners. So I'm just going to plan out where those guys ought to go. So let's put one right there and see how it turns out, and then I'll put another one over. Oh, it might fit. Let's put in some automation wires so that the space scanners can control those bunker doors. I'm going to not connect this right away. I'm going to build all of the wires, but I'm not going to connect them together right there. I'm going to wait. And that's because I don't want my bunker doors opening up in the middle of a meteor shower because this automation isn't all finished yet. So one of the things that'll happen is regolith is going to fall through the bunker tiles and land on these airflow tiles. The petroleum that's on the airflow tiles is going to rise. I mean, regolith sinks, so the liquid that's on the airflow tiles goes to the top of the regolith, and it will poke out the top of up here on top of the regolith. If the regolith is very deep, it will poke up into places where there is space exposure, and we will lose some of that petroleum. My feelings on it are, let's build another row of drywall so that the regolith can get this deep until the petroleum pokes out the top. But let's also keep in mind there's very little petroleum on these airflow tiles. We're not going to be losing much, and I don't want to make a whole ordeal out of like trying to drywall this whole area up here. So I'm just going to put one more layer of drywall because usually that's about the limit for how deep the regolith gets. Let's do the solar panels. Forgot to I forgot to stop the. There's way too much water in this the steam turbine room. How much is in there? 287 kilograms. It doesn't say they're flooded. I guess I'll just deconstruct that bottle emptier and I'll put in the walls and we'll call that done. And as long as they're not flooded, I guess it's okay. Down here in the steam room, we have 373 kilograms. We're not ready to really start this thing up yet, so I think I'm just gonna I'll let that fill up some more. Assuming the automation is all in, looks like it is. I can just connect up our bunker doors, and when the meteor shower is over, they will open, and we can start seeing this thing work for the very first time. All right, so our regolith is going to fall in here for the first time. The first time is the easiest one because nothing is warmed up yet. Our temp shift plates down here, for example, are only 40 degrees. The regolith fell down to the bottom. By the way, in case you didn't know, like the petroleum when it's sitting on top of airflow tiles, you can't see it. It's just the way airflow tiles are. Now that the regolith has fallen on top of it, you can see the petroleum on top of the regolith. It's being cooled off by the temp shift plates, and that prevents it from being too hot. So it does not damage things like the RoboMiner, which is buried in here right now. These RoboMiners are all buried, which means we're going to have to wait for this one to start digging them out because this is the only one that can't get buried. The cooling is still happening. Our coolant moving through this pipe is, well, it's still doing its thing, cooling stuff off. Remember, this thing is built for, to handle the entire sky, and we're only using it to cool down a quarter of the sky right now. So don't expect too much action from it. We don't need any more water in here. And I will close up this room. There we go. Our regolith is still getting removed. You see, we're getting light shining through to these solar panels, so they're doing their job. I see I have made a poor choice and made some of these ladders up here out of plastic. I am going to undo that. The problem is that regolith will, like what it did right here, it stacks up and melts that plastic. And when that happens, the plastic melts, turns into naphtha, and naphtha gets down in here like it's doing right there. You see it? There's naphtha right there. It's in the way of the petroleum that's trying to run down these steps, and it causes problems with our whole cooling setup. If you use the materials overlay and switch it to liquid, you can see where that naphtha is. You see we have some right here and we have some right there. I'm going to use the sandbox to get it out of here because I don't want to deal with it. But in your game, just keep in mind that if you make things, if you get other liquids up inside of this that you don't want there, it'll mess up your cooling strategy. Let's get rid of, where's that overlay again? Liquid overlay. Let's get rid of that naphtha and that naphtha. The auto sweepers put stuff in the auto loaders, and the auto loaders put it on the rail, and the rail takes it away to do whatever you want with it. And what I'm doing is I'm just dropping it right there on this tile. Oh, geez, there's something that I missed. So you want to put a tile right up here at the top above the ladder. Otherwise, regolith will fall straight down the ladder and pile up at the bottom, and your dupes will get stuck up here. And so if you put it there, it's not in the way. And our RoboMiner can reach the top of that so it can clean off the regolith that lands on top of it. I'm not sure that my choices with the scan network is good enough. Okay, it actually is good enough. I think you need like 40 seconds, 45 seconds, something like that, notice in order to close the bunker doors before a meteor shower starts. And this scan network is at 51 seconds or more, so it is sufficient for the job that we want it to do. I'm going to cheat with the sandbox and fill this up with steam just so that we can get a more accurate demonstration for what happens when this whole thing gets up to temperature. So let's have a quick look at the good characteristics of this. Number one, it's almost entirely transparent. Let's have a look at that actually. So up here on the top, We have 70,700 lux. Down here below it, we have 70,489 lux. So we only really lost like 200 or 300 lux going by shining through the petroleum, and everything else really is 100% transparent. The petroleum will be deeper up here. I think it will be. So it's 70,767 lux above, and below it is 70,212. So we lost about 500 lux. It's less than 1% of the light. And for me, I find that very much acceptable. There's no holes in that. Like everywhere where the build is, there's no shadow. I didn't build a single thing up here that wasn't completely transparent to the light that's coming from space. The next good characteristic is that we can sweep everything. Anything that lands up here on the platform can be swept by the auto sweepers and put away. And that actually, I think, getting those two things together, the transparency plus the auto sweeping, that's really hard to do in a setup for space. At least it has been in all of my experience. Unless, of course, you have thermium, but once you have space age materials, there's a lot of things that get easy. And I know you guys well enough to know that you want to know how to do these things without space age materials. What are my other characteristics that I thought are good? Well, first of all, it's simple. My other favorite space setups, they're just not that simple. They have like a bunch of mesh tiles and complex patterns in order to catch regolith to stop it from making everything overheat, and also provide access to through with an auto sweeper so it can sweep up all of those things. And as far as I know, there is exactly one pattern of mesh tiles that make that possible, so that you can get the auto sweepers and the auto loaders and the auto miners all in, and with the mesh tiles so that regolith doesn't fall on anything. There's exactly one pattern that I'm aware of, and I worked real hard trying to find other ways to do it. So, which is complicated. It's also completely not flexible. If you change anything, it doesn't work. You can't do things like stick a large power transformer up here. If you want to make a hole in it so that you can launch rockets, which of course you want to make a hole in it to launch rockets at some point, right? Yeah, you can't, not without making parts of it that don't work right. This build is exactly the opposite of that. It's crazy flexible. You can go in here and move around these auto miners, these robo miners. I didn't even plan out where I preferred the auto sweepers to be. I made it up as I went along as I built this. And so it turns out to be incredibly flexible to do it this way. Maybe to you that doesn't seem like an important quality, but I've messed around with space setup so much, I cannot understate how valuable it is to be able to move these things around. Like a lot of the things you build are like in a room and you never touch it again. Your space setup isn't like that. You're always going to be doing things to it, and it's very valuable to have it be flexible like that. A lot of space setups are also really big. Like this is thin. Like I know there's a whole dip in it, so if you count all the way from the top all the way to the bottom, it's 1, 2, 3, 4, 5, I don't know, like 10 or 12 tiles. What are the other good characteristics of this? Oh yeah, of course, it doesn't use space age materials. I only used steel for all of the stuff on the platform up here. And I think that's reasonable because, I mean, you have to have steel in order to make the bunker doors anyway. I can't think of anything else I need to say about this right now. So I'm just going to let this run, and we'll have a look at a couple more meteor showers. Okay, this meteor shower is just about over. Now, I paused it for a second so we can watch this happen slowly. Here's the regolith falling through the bunker doors and landing down here. The regolith is hot, obviously, or it was 300 degrees. But the temp shift plates down here, which are currently, like that one's, this one is 150 degrees, will cool down this regolith very quickly to a reasonable temperature. Ooh, check it out. Okay, so this tile of regolith is 350 degrees. I'm going to just unpause it quick and then pause it again as quickly as I can. There. And now it's down to 223 degrees. So it went down 125 degrees, and that's why this setup works, is because those temp shift plates cool down that regolith real quick. The robo miners are chewing out all of the regolith chunks, and also the auto sweepers are putting away the regolith chunks. And let's see what the kind of temperatures we've got right now. So right now the temp shift plates are at, this one's at 160, that's pretty good. 209. They seem to get increasingly hot as we move up here to the left, which makes sense because I guess the petroleum would pick up that heat and bring it down the stairs. The regolith tends to be about 300 degrees, and these appliances are safe, like their overheat temperature is 275. So most of the time, the change in temperature only has to be like 25 degrees for the regolith to no longer be too hot. So really, this is not only a very fast way to cool down the regolith, but probably massive overkill for keeping all of our appliances safe. All right, so now we're getting a look of more what this will look like once everything is warmed up all the way. So this makes sense to me. This steam turbine is getting most of the heat and from this pipe because that's where the pipe is, and this one is picking up a little bit of the spare change that's left over, and this one probably will almost never turn on because the heat doesn't tend to move all the way down through the steam room. If we were cooling down regolith for the entire sky, then all three of these would run, probably not quite up at their capacity, which is exactly what I wanted to do. I'm going to wait for one more meteor shower so that we can have a look at the dynamic for how this works, and then I'll call that the end of the video. All right, that was like the shortest meteor shower ever. So the regolith is falling down in here. It's getting eaten away by the robo-miners and then swept away by the auto sweepers. As you can see, so the auto sweepers are starting to fill up that conveyor rail. And it's pretty much done. I don't think our temperatures are going to change too much after that because it was such a small meteor shower. It's still making our steam turbines down here run a little bit to do the cooling. Okay, I think that's good. I stopped recording and I built out this thing to cover the entire sky and let it run for a while to make sure everything seems to work as expected, and I think it's quite good. I will provide you guys with some kind of a link somewhere to a copy of this save file so that you can try it out and, I don't know, make blueprints of it or whatever it is that you like. I've been working real hard on something for the last couple of weeks. You might have noticed I haven't posted anything new during that time. And being able to do this stuff will facilitate being able to do that stuff. And I'll have videos for that done soon. For me, the hard part of making videos is that it takes a really long time to learn how to do stuff. The actual recording and editing isn't awful. Well, it's like a day's worth of work, but that's compared to the amount of research I do. That's not the hard part. That's the easy part.